Okay, can you see the slide that I'm showing now?
Yes, sir.
Yes, sir.
Yes, sir. You can see.
Okay,
Yes, sir.
so today it would be like introduction class where we'll be discussing some basic properties of soil, and since we'll be discussing soil exploration in our next chapter, so that's why we need some basic discussion on the soil properties. Though you have studied this soil properties in geotechnical engineering 1 just last semester, maybe you are expert on it. So let's discuss some topic that you are expert on, right? Okay, so before going that, I'll formally start the introduction. Like in introduction session we already had in last class, that is in the morning. So we introduce ourselves, right? We had a like introduction with each other, then we discuss about the course outline, right? And I already upload the course outline in the Google Classroom, so you can find it there. And we'll be discussing the content of Geotechnical Engineering 2, especially from this book, that this textbook, that is Principle of Geotechnical Engineering, that is the 7th edition of BM Das. So I will share the lecture notes, that is the slides, also the chapter wise PDF file of this book, so you can combinedly study both of the materials for your better understanding. So you don't have to buy, since no way to buy now. Okay, so the aim of this lecture, or the target of this lecture, is to discuss about the soil properties. Okay, and we're expecting that we'll understand the basic soil properties. I think you already know, so I can say expectation from you that we can review the basic soil properties, and we can apply this fundamental of soil properties to the next chapter or next lecture, that is we'll be conducting in the next week, that is called soil exploration. So it's basically the soil testing. Okay, so before going to the main discussion, so I just want to ask you a very simple question, that is why geotechnical engineering needs to be studied, or why do you need to study the geotechnical engineering? Is there any idea from your side? Though answer is showing, but is there any personal opinion from your side?
Try to find out the soil characteristics.
Okay, then any more?
Sir, all loads taken by soil. That is, soil is the main theme in this engineering sector.
Sir, structure is mainly based on the soil. That's why we need to know the properties of the soil.
Okay, good point.
Sir, sir,
Okay, so by the way, so
because
everybody are right to some extent. So whatever the answer you are telling is okay. So to be more specific, actually whenever we think of any structure, that we know that load needs to be transferred from the superstructure to the foundations, right?
Yes, sir.
So foundation is based on or upon the soil, right? So it located just upon the soil or inside the soil. So that means indirectly you're transferring the load from superstructure to the foundation, and foundation is transferring the load to the soil. So you need to know, so to design some foundation you need to know this load transferring mechanism. This is one things to design the foundation. Then secondly, you need to know the regional code, or the regional building code. Regional building code, like if you're designing in Bangladesh, you're following BNBC, right? Even in Bangladesh, if you follow the if you're designing for Dhaka, it might be one region. If you're designing for the like some hill track area like Chittagong or some other belt, so the designing criteria might be changed. Okay, and the stress related to the deformability of soil to support foundations. So while the structure or the building is transferring the load to the foundation and foundation is transferring the load to the soil. So this is the soil particles, or soil particles needs to resist this load, right? Are you getting the concept? So soil particle
Yes, sir.
needs to resist the load. So that's why some stress is developed there. So we know where is the load, there is a stress. So due to this stress, soil has a tendency to deform. It might settle down, it might fail in shear, right? So there are several phenomena it can happen. So just we need to know this scenario, that is the deformability of soil, how it's going to deform due to the load. Stress indirectly considering or coming from the load application, right? And finally, that is the geological condition of the soil with design consideration, right? Geological condition. So like in different geological location, different soil properties, different ground conditioning you'll find, right? So based on this geological condition, you need to consider the design parameters also. Suppose you maybe have some idea about the structural analysis, right? Wind and earthquake, right? You have it? You have any
Yes, sir.
idea on it?
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
So there you can see there are so many factors are being changed due to the locations, right?
Yes, sir.
So similar conditions for the geological condition also, if it is depends on the soil. So different parameters or factor will be changes. We can see that two factors of last two factors from these four we can find are related to the soil mechanics, right? One is the stresses coming and there is the geological conditions. So both are related to the soil mechanics, that how load is being transferred from foundation to the soil, right? So definitely you need to know the behavior of soil while you apply load. So this kind of behavior we understand in the mechanics. You have studied the basic mechanics, right?
Sir.
So in
Yes,
basic
sir.
mechanics you can see how load is transferring or how the reactions is coming when you apply some load, right? Pattern of
Yes, sir.
reactions, amount of reactions, this kind of issue you studied in the basic mechanics. And in case of solid mechanics, you studied how reactions or actions is passing through by solid materials,
Yes, sir.
right?
Yes, sir.
Similar way, you did the fluid mechanics
Yes, sir.
where you have studied the mechanism of fluid. So this kind of informations also can conclude you that what sort of things is soil mechanics, right? How soil is behaving or how soil will be behaving while you apply load, and for which type of soil what would be the behavior and what would be the consequences after having loads, right?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
so according to the BM Das book, we can find the foundation engineering is a clever combination of what? Soil mechanics, right? Then engineering geology and proper judgment derived from past experience. So these three things combine together to make you a good foundation engineer. So what is that? Soil mechanics, you should know what is the behavior of soil or how soil is acting, and engineering geology, so, and past experience. Sometimes the test you are to discuss something from your previous experience. Maybe you are very much well known on a area that maybe it was a pond before. Suppose 10 to 15 years back it was pond, right? But maybe someone fill up this land and now that people wants to do the construction on that land. So though the soil properties of the initial level is very good, but you can think of it, okay, so I can see last 15 years or before 15 years it was like a pond, so I need to dig it down more, right? Because the
Yes, sir.
upper layer soil property is the newly filled soil property. So this property is not exactly the property of soil you're looking for. Okay. So, and in case of application of geotechnical engineering, so you can see there are so many applications. Actually, none of the structure is possible without the soil, right? Any structures you need to rest on soil, either inside the soil or on the soil. Okay. So here you can see some of the like regular example of building, roads, bridges, dams, tunnels, or water tanks, whatever it is, are constructed on, either on or in. You see, on or in. What does it mean? Either upon or inside the ground. So what is the essential part here? The ground. So ground is made of soil. So ultimately soil is the issue, and engineers are required to assess and avoid the major risk posed by the ground conditions. So you can see ground conditions need to be familiar for you to avoid the risk. uh, do you see any failure due to the soil reports or other things in your country?
Yes, sir.
You'll find many a times you'll find so many structures are failing due to the soil report. Okay. Anyway, so these are some examples, like you can see some offshore structures which is also in water, but still the foundation is on where? In the soil, you see. And in case of some construction on the soft soil, here you can see this is the soft soil layer. Sorry, this is the soft soil layer, right? So they fill up this layer, okay, with some improved soil, then they construct this structure. And some roads, definitely it is on the soil. And some tunnel, you can see. Do you know there is a tunnel construction going on in Bangladesh?
Yes, sir.
Yes, sir.
Where is it?
Yes, sir.
Sir, Chattogram.
Yes,
Sir, Cornopoli tunnel, sir.
Yes, sir.
in Chittagong, Karnopuli tunnel.
Sir, Conductivity.
Yes. So now, have a look. Sometimes you will see that, okay, construction is going on and the site is covered, right? And you find there is a like ditch like this. It looks like pond. They are making pond, right? And they put this kind of barrier to protect the soil, right? Do you know what kind of foundation this is they are making there mainly? Yeah, this is sheet pile, the to what is called, to retain the soil. But here they are putting mat foundation, this one, can you see?
Yes, sir.
They are putting mat foundation, and this is void, so that's why they need to retain the surrounding soil not to come here. So that's why they put or insert sheet pile. You understand? Maybe in Dhaka city or maybe in some
Yes.
city areas also you'll find this kind of construction.
Yes, sir.
Okay. Okay, so in
That
case
is
of
the
building dams, so you know everything is rest on the soil. Okay, so can you see this slide? Focus on the course. Focus of the
Yes, sir.
course.
Yes, sir.
Okay.
Yes,
Yes.
sir.
So this is actually the outline that which topic we'll be discussing from which chapters. So like geotechnical properties and exploration of soil, we'll be discussing from chapter 1 and 2 combinedly. Okay, so this is just guideline that while you find so many lectures has been conducted and you're confused, studies discussing shallow foundation, where is the chapter is it? So these kind of things. So foundation analysis will be like gone through from chapter 3 to 13 for these shallow and deep foundations. And in case of lateral earth pressure and earth retaining structures, we'll be following the chapter 8 sorry 7 and 8. And soil improvement from chapter 14, which from which book? That I I consider as a reference book. You remember?
PM does.
Okay. So now come to the soil properties. You can turn on your microphone if you do not have any noise, but if you have noise, please make it off. If you have no noise, you can turn it on. You can respond with me. So I feel more comfortable of taking classes. Okay. So do you know in Geotech 1, you did some testing, right?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
You did some soil testing, right?
Yes,
So
sir.
can
Yes, sir.
you recall the name of this soil testing, soil test?
Like sir,
Sir,
CBR ratio test.
particle size distribution, sir.
Okay. Then
Classification of soil, sir.
classification of soil.
Soil, soil compaction, sir.
Soil.
Soil compaction, sir.
Soil compaction. Anyway, so we have discussed so many tests. You had some idea on the tested. So from the test you did in the last semester, what was the main purpose of this test?
Know about the soil properties.
To know about the soil properties, exactly, because you want to get more idea on the soil properties and soil behavior. Okay, so that's why these informations are needed to amplify your next learning, like grain size distribution. You need it, plasticity, soil classifications, hydraulic conductivity of soil, then effective stress considerations, and shear strength parameters. So these are the things you need to review for your better understanding of the lectures. Okay, so I think you did this grain size soil distribution, right?
Yes,
Yes,
sir.
sir.
So for grain size, we do sieve analysis for the coarse grain soil, and we do hydrometer analysis. We do hydrometer analysis for the fine grained soil. So now, can anybody tell me why we do hydrometer analysis for fine grained soil? Why not sieve analysis? Let me ask some questions to specific person. Ahmed Shajal.
Because the
Ahmed Shajal, why do you conduct fine grained soil analysis uh, by hydrometer? Why not sieve analysis? Ahmed Shajal, can you hear me? No response. Arif Sheikh?
Yes, sir.
Sir, fine soil, it's mean if the uh, diameter is very low, that is why
Okay.
cannot it
Yes.
cannot count by sieve analysis. That is why we use hydrometer analysis.
Hmm. So diameter is not low, diameter is small, right?
Yes, sir.
Okay. So diameter is very small, particle size is very small. So that's why we cannot do the sieve analysis. So
Yes, sir.
we go with the hydrometer. Okay, very good. So I got the answer. So what is the main target of doing this analysis, or the like sieve analysis and hydrometer analysis? What is the main intention of
fine,
doing this? Chad Mahmud, what is the main focus of doing this test in your experiment, right? Maybe you did in Geotechnical Engineering 1.
So my concept is that the soil, we can easily identify the soil dense or not dense by the hydrometer testing. Actually, I don't know, sir, the correct answer.
Okay. Mahdi Hassan. Mahdi Hassan, can you hear me? No response. Anyway, so next time I will consider this issue as a class performance. Okay. Who can answer this question that I said? What was the main intention of doing this analysis?
Sir, find out the fineness modulus.
Yes, sir.
For
Finance
coarse
modulus.
analysis.
what we'll do with the fineness modulus. Suppose you know the fineness modulus. So what is the use of its fineness modulus?
Find out the maximum particle size, average particle size.
So what is the use of finding this maximum particle size and average particle size?
So because soil compactions, how soil will be compact, and hydrometer test we do the in the soil, how much dust and other materials are included in the soil. That's why we do the hydrometer test.
Okay, anyway, so basically I got some good point from you, but I can add some more with you. Basically we want to know the distribution of particle. So how these particle size are distributed. Maybe in civil engineering materials you did CV analysis for the fine and coarse aggregate, like for the sand and the brick chips or the stone chips. There you have found that if the uh, materials is well graded, there is a chance to have a less void, right? There will be higher rate of compaction while you do for the casting.
Yes, sir.
Yes, sir.
Am I right? This is very
Yes, sir.
basic concept. So if
Yes,
the
sir.
gradation curve is well graded, so we have a higher chance to have a less void, so our concrete will have more strength than void concrete. Okay, so
Yes, sir. Yes, sir.
so from the gradation curve we can see what could be the density expectations from the concrete or something like that. So similar that also for the soil, so we can have some clear concept how much denser the soil would be and how properly the grain size is distributed. So only the size or grain size distribution we can find out. Okay, so I'm not going to discuss the in details how you did the CV analysis, because this is the part of your last semester study. I hope you can understand, and you did the experiment also. And this is the fine grains test, that is the hydrometer. You have seen this, right, in lab? Did you use this kind of hydrometer in? Yes, no, what? Can you hear me?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay,
Yes.
some of you can turn on your mic actually to give me the response, otherwise I feel bored. Okay, so this is size limitations, actually how we consider the gravel, sand, silt or clay. So here we can see the unified standard is considering three, that is the gravel, sand and silt and clay in same category, and ASTO is based on American, so they categorize individually. So I think this is nothing to be memorized, but just to understand, because every time you go for design or design of soil, design of foundations, you have this chart, but you should know which chart define which one. Okay, and this is actually important for you because mostly you will be using this. Can you see? Still, can you see?
Yes, sir.
Okay,
Yes, sir.
so this you can find, that is the weight volume ratio. So many parameters are here that you need to understand. I hope that you already are expert on these parameters, like what is void ratio, okay, then what is porosity. So void we denote by E and porosity we denote by N. So degree of saturation, moisture content, right? These are the parameters are really important for your further study, because here you need to study what is this and why we are using this. But in next lecture we are not going to use this or we are not going to explain it as it is now. We'll be just using, okay, gamma d, gamma SCT or gamma, right, or rho, something like that. You understand the point?
Yes, sir.
And that's why you just
Yes, sir.
Yes, sir.
that's why you just need to review this chapter. I hope that you already know this and you can review this for the next chapter's understanding. Okay, and now come to the relative density. So relative density, what is relative density? Can anybody explain what is relative density? Yes.
The ratio between the density of a object with water.
Sir,
Anyone?
density is the ratio between the objective of any particle divided by density of water.
Okay, but here they are considering the relative density.
So comparing any materials with other materials,
Mm-hmm.
so we have to compare first
Hmm.
with others. They have to
Okay.
relate.
I think they're comparing the soil
Represent
compaction before and after compaction.
Sorry. Can you repeat?
Density
Sir,
density of the soil before, like the normal density of the soil before compaction compared to when it is compacted.
So before and after, right?
Yes.
also like, sir, materials dry and wet.
Okay. So actually, why we need to study this one? What is the information that we can get from this relative density?
How much load or how much how much load the soil can take under constant compaction due to everyday use.
Okay. So indirectly, you're right. Actually, we can get idea how much more settlement this soil can occur, or this soil can participate while you apply load, right? So indirectly, Laviv answer can be right, that okay, capacity of the soil also depends on the relative density, because while it is going for the settlement, that time we do not allow the settlement more than that, right? So on that case, on that case, we consider that okay, we will not allow more than that settlement, so we will not allow more load. So from the relative density, we get idea how much compacted this soil is, right? So this is one of the parameter. So while you go for some designing, that time you will find this is a factor. This is a one of the factor. What factor? Okay, so in case of relative density, why I'm considering for foundation design also, you can also consider this relative density as a factor. Okay. Okay, this is actually just a soil classification system. So there are so many classifications tables you'll find in the book. So just don't worry, you just look into this book and you just get some idea. You don't have to memorize anything. Okay, so this is another important part, that is called Atterberg limit state. Okay, so where you will get that very clear concept of three state of soil, that is the Atterberg limit: liquid limit, plastic limit, shrinkage limit, and from these we can find out the plasticity index. Okay, so if I briefly discuss for your better understanding, this is what shrinkage limit, right?
Yes, sir.
Okay, so if I come from here, have a look. This is moisture content of soil. Can you see the graph?
Yes, sir. Yes, sir.
You can see the graph, right?
Yes, sir. Yes, sir.
I can make it more visible. Now is it more visible or not?
Yes, sir. More visible.
Okay, so have a look. This is the moisture content and this is the volume of soil water mixture, right? So indirectly this is the volume, right? So have a look.
Yes, sir. Yes, sir.
Once the moisture content increases, that means what? The content of water, right? Water is increasing. So after this line, or after this limit of water, if you add little bit of more water to the soil, it will go to which limit?
Sir, liquid.
It will move to the liquid, right? So then it can be classified in a semi-liquid, liquid state based on the water content, but it moves to the liquid limit. So if you reduce some quantity from this limit, what will be the situation? The soil will behave like a plastic situation. Okay, so this range is considered what? Plastic limit water content. So if the water content is from this point to this point, okay, you can see the soil behavior will be plastic limit state. So you know, okay, and this state we consider the semi-solid state. So water content from this to this limit, that would be the consideration of the semi-solid. Okay. Okay, so please study, everything is here. And plastic index,
Sir, if you give an example of 4 step, it will be more helpful for us to understand this limit.
oh, liquid limit is like which can flow, right? Plastic limit which cannot flow, but which you can easily change the shape, right?
Okay.
And
Yes.
solid,
Yes, sir.
and in solid you cannot do any shape, right?
Yes, sir.
Yes, sir.
Okay. And this hydraulic conductivity of soil. What is hydraulic conductivity? Any idea? Hydraulic means what? Water, right? Water is
Water is passes
water is
for us.
moving in case of flowability of the water. And in case of effective stress, I think stress is clear to you. If it is not, then I will explain again now. What is stress? Make it
It's the
faster.
force by area, sir.
Yeah, force over area. So how much
Yes, sir.
load can be taken based on the soil particle size? That is we call the stress. Okay, so the total stress at a given point of load in a soil mass can be expressed, that is sigma prime and u. So what is sigma prime? That is the effective stress, and u is the pore water pressure. So in soil you might have the load from the soil particle, and also you have a pressure from the water, right? So that is the
Yes, sir.
total stress. But effective stress is only stress coming from the soil particle. If you think of soil particle, something like that, okay, so okay, sorry, maybe, but these particles are together, right? Can you see the particles? Hello?
Yes, sir.
What happened to my slide? I don't know. Okay, can you see the soil particles, the three rectangles?
Yes, sir.
One particle is connecting to another, right?
Yes, sir.
So if this particle is transferring the stress to this, and this particle transferring the stress to this, so this is called exactly the effective one. No water pressure will be considered, only stress coming from the particle to particle, right?
Yes, sir.
Okay,
Yes, sir.
so almost finished the lecture. So this is the last slide, maybe just last topic, compressibility. So you can see there are some different compressibility in uniform settlement. So it goes gradually, like have a look, each corner of the building settling in a same rate, right? And
Yes, sir.
this is the tippling, like one side is settling, and if it is not settling in a same rate, suppose this side is settling higher, this side is no settlement, so it will go for the differential settlement. So this lecture will be discussed again in details during the settlement chapter. There's a similar scenario for the before settlement occurs, uniform settlement. Have a look, the total structure settle at together, but differential, the structure does not settle together. There is no settlement, there is higher settlement, right? So which one is vulnerable?
Yes, sir. Uniform settlement.
So partial settlement.
Yes, partial settlement is vulnerable. It creates the failure.